Welcome to The Explainer. Today, we're diving into the Hybrix natural farming operating system to, really get our hands dirty and build an incredibly powerful, totally plant-based nitrogen source. Okay, so let's unpack this quote because it really gets to the heart of the whole HBNF philosophy. On one hand, you've got fish, which act like a filter, soaking up whatever's in the ocean. On the other, you have a legume, a pulse, which is like a clean battery, just storing up the sun's energy. It's all about choosing the cleanest, most efficient fuel for our plants and dodging all those hidden biological costs. And that choice brings us right to a huge challenge in farming: nitrogen. Plants absolutely need it for protein synthesis. That's the bedrock of level 2 on the plant health pyramid. We're talking growth, immunity, the whole shebang. So the question becomes, how do you provide that critical fuel without using animal-based inputs like the typical fish amino acid? Right. And here's the crucial point. We're not just trying to throw raw nitrogen at the plant and hope for the best. The goal is to provide the finished building blocks, the amino acids themselves. It's like giving the plant a pre-made meal instead of a bag of groceries. This saves it a massive amount of energy that it can then put to use somewhere else. So what's the workaround? What's the alternative? Well, the HBNF system offers this incredibly elegant solution. It's a way to create a potent, completely vegan amino acid source, and you can do it right there on your own farm. And that brings us to our star player, mushroom amino acid, or MAA for short. As you can see, it's designed from the ground up to be a direct one-for-one replacement for fish-based fertilizers. It delivers all that same protein-building punch, but from a purely fungal source. Now, the HBNF protocols are super specific about this. They call for oyster mushrooms. So why oyster mushrooms? Well, for one, they are just jam-packed with complex proteins, which makes them the perfect raw material. But you're not just creating a nitrogen source here. You're essentially making a vegan fish hydrolysate that also brings these unique compounds to the table that can actually help modulate the plant's own immune system. It's pretty amazing. So, the big question, how do we actually make it? Well, the HBNF operating system is all about practical application, and it gives us two really distinct protocols to choose from. Let's start with the foundational, kind of low-tech method. This is the classic osmotic method. It's simple. You take your mushrooms, and you use an equal weight of sugar. The intense osmotic pressure from that sugar literally pulls all that good, nutrient-rich liquid right out of the mushroom cells. Now, it does take a few months, but what you get in the end is this potent, fully preserved, and totally shelf-stable amino acid concentrate. But what if you need that nitrogen power, and you need it fast, like right now? For that, we've got to upgrade our system a bit. We need to bring in a specialist biological tool. And this is a brilliant illustration of what HBNF calls metabolic precision. We bring in this stuff called Nuruk. The system calls it the enzymatic key, or even the unzipper. And instead of just passively waiting around for fermentation to happen, Nuruk lets us actively engineer the digestion process using its own powerful enzymes. With this method, it's so much faster. You just create a mushroom slurry with some water, add the Nuruk, and then you just let the enzymes do all the heavy lifting. These little biological scissors get to work immediately, just snipping those complex proteins into ready-to-use amino acids. The whole process? It's done in about a week. This table just lays it all out, plain and simple. See, there's no single best method here. It really just depends on what you need. If you want to make a big batch that you can store for a long, long time, the osmotic sugar method is your go-to. But if you need a powerful nitrogen source for your crop right now, well, then you fire up the Nuruk engine. Okay, so we've built our vegan nitrogen engine. We've got this incredible amino acid source ready to go. What's the payoff? What actually happens when we apply this stuff to the plant? This number is everything, 16%. According to the research that underpins this whole HBNF framework, a plant has to spend around 16% of its total energy from photosynthesis just to turn raw nitrogen, like nitrates, into the amino acids it can actually use. That's a huge energy tax. And here it is, the bottom line. By giving the plant our MMA, we are literally handing it back that 16% of its energy budget. The plant doesn't have to waste it on basic chemistry. Instead, it can reinvest that energy surplus into achieving level 3 health, building fats, oils, and that waxy cuticle that acts like a physical shield. And in the real world, that means healthier, more resilient plants that can fight off diseases like powdery mildew and put way more energy into giving us higher quality, more nutrient-dense food. So there you have it. This explainer gives you the complete blueprint. You have the slow and steady osmotic path, and you have the high-speed enzymatic path. The only question left is, which engine are you going to build to give your plants the clean, powerful nitrogen they need to really, truly thrive?